Welcome to Buildings and Beyond,
the podcast that explores how we can create a more sustainable built environment
by focusing on efficiency, accessibility, and health.
Hey, I'm Robb. In this episode, I talked with Christine Liaukus and Adam Stenftenagel. We talked about improving efficiency of homes, mainly existing homes, single-family homes, or at least low-rise. Adam and Christine come at this from different angles, but I'll let them describe those angles. But this was really cool discussion. I really enjoyed it. Before we dug into things, I asked them to introduce themselves separately, starting with Christine.
I'm Christine Liaukus, and I am a registered architect and certified passive house consultant. I am at the Center for Building Knowledge at the New Jersey Institute of Technology, and I've been focused on energy efficiency and sustainability for a long time, since my days back at Stephen Winter Associates working on the Building America program. And the thing that I'm focused on most right now is something called opportunistic retrofit, which I know we're going to be talking about today. So I'm very interested in making existing buildings more energy efficient, since that's mostly what we've got to work with.
And I asked Adam to introduce himself.
My name is Adam Stenftenagel, and I am the CEO and co-founder of two organizations, Snug Home and Radiant Labs. And both of our companies focus on really energy modeling and energy just analysis, cost-benefit analysis, and the financial calculations around doing energy improvements on buildings. They're software companies. They got different roles and whatnot. Snug Home is energy auditing tool that's largely used by contractors in government and utility type programs. And Radiant Labs is trying to take a little more of a market direct approach and focusing heavily on building electrification and the more large scale deep energy retrofit space through both public policy, providing tools and analytics and APIs for the public policy folks, as well as direct to consumer.
Well, thank you both for being here. This is a cool topic, and I had talked to you when I was thinking about doing an episode about improving, performance, efficiency of single family homes. I had kind of talked to both of you separately, and you're both kind of coming at it at different angles, and I thought it'd be kind of a cool discussion to talk about both angles. And Adam, your angle, correct me if I'm wrong, is a much more comprehensive approach. So really, and you mentioned deep energy retrofits, and from an energy geek's perspective, that's kind of the more interesting and appealing and exciting. You're going all the way, getting to zero energy or whatever with existing home. Can you, briefly talk about if that's correct, if that's kind of what you're kind of pushing, and briefly why and how you're pushing that track?
Yeah, thank you. What's so interesting is that, when we started out with Snug Home, we were like, well, any kind of efficiency is great. Like whatever carbon savings we can convince the homeowner to do, we'll take it. Right. And so you started getting, the programs and the, city and state governments, all the folks that were for pushing this kind of stuff in the utilities, they're getting some carbon savings, and that's good. But when we decided and realized that we were not really making a dent in real carbon reductions, and that we had to go so much bigger, it shifted the concept a lot. And so we got this idea of building electrification that started coming along. We were talking about it in 2014, but it's really the talk now for all the different government programs and the utilities are talking about it. So it's starting to happen. And building electrification is an interesting little character because, we've got some great new technology, heat pumps that can heat the house with electricity way more efficiently than electric resistance heat, of course, but even way more efficiently than the heat pumps of your parents and your grandparents in the Midwest, kind of thing, right? So it's very different world of technology. So we're like, great, now we got some new tech. We've got induction cooktops instead of gas stoves, really precise, amazing cooking experience. We've got heat pump water heaters, just phenomenal energy savings that you can get out of those things. And so there's this big push towards electrification, but it doesn't always work in every circumstance. And so when we started Radiant Labs, we were trying to figure out what are the situations where electrification makes sense and what do you have to do in order to get it to work? And then how do you get it to be financially viable? And so with that in mind, you start looking at, well, how do the heat pump systems get deployed? Like, what do you need to do in the house? Most central heat pumps can produce at most 40,000, 45,000 BTUs an hour at the coldest of the cold temperatures outside. And not a lot of homes only need that much energy, in order to keep the house warm, at least without improvements. So building envelope improvements become absolutely crucial, especially in the cold climates where these heat pumps can actually keep the house warm. Like, they can do a good job, but the load and the sizing of that equipment has to be able to match, what the house needs. And so envelope improvements have just become crucial for even getting these heat pumps deployed in many of the climates throughout the country. California, no problem, right? Very mild, not a big deal. They work everywhere. You don't even need cold climate heat pumps in California. But in a lot of the places we were looking, Colorado, where we started our company, and in New York State, which is one of our biggest clients right now, it's very difficult to get those houses down to even 40,000 BTUs an hour, right? And so you gotta go pretty deep to do that. The other piece of the puzzle is, even if you had a heat pump that was sized right and could do the work, if you've got really cheap natural gas that you're trying to do the economics against, they just absolutely don't pencil out from an operating perspective, right? From an operating cost perspective. And so you have to think bigger than that, right? At 72 cents a therm, which is what gas used to be in Boulder only a couple of years ago, compared to 12 or 13 cents a kilowatt hour electricity. Even an 80% efficient gas furnace was still less in operating cost than a high efficiency cold climate heat pump. And that's just not going to work, right? You're not going to convince people to pay more for this new technology, even if it does potentially save the planet. So the thing that we had to bring into that picture is rooftop solar. Rooftop solar, amortized cost of rooftop solar is so much less than your grid electricity. If you've got net metering available, it's a no-brainer. And so, I did this work at my house. I had just moved to Florida last year and bought a 1955 house in St. Pete, and we, did the rooftop solar. I got this installed for $2.60 a watt with a 25-year production guarantee. That comes out amortized cost for, like, if you calculate the total amount of electricity that I purchased and divide it by what I paid for it, I'm paying 5 cents a kilowatt hour for my electricity. Right?
For 25 years?
For 25 years locked in.
Yeah.
Right? So that's the kind of stuff that we're looking at, because you may need solar to make the heat pumps make sense. You're probably going to need envelope improvements for the heat pumps to make sense. There's all these different interactions between the pieces of the puzzle that are really important. And so, I just say, as we look at all these new rebates coming in, we can't just throw heat pumps randomly at the wall and hope they stack. Right. And you can't just train the contractors on how to install the heat pumps. You need to make sure that they've dealt with these other issues, that they've dealt with the load, that they've made sure that the economics are actually viable for operating costs. So that's what our software is really trying to help drive, is the education around that and the modeling to help you figure all those pieces out. So
let me see if I heard you right. So your focus, you're going big. You're going, envelope improvements, load reductions, PV. The first driver for that was electrification for carbon reasons.
Yes.
And then it was load reduction just so heat pumps would work better, and then PV just to be cost effective. Is that
that's a good way of putting it together? And throw in an electric car and the economics are even better, significantly better, right? So yeah, that's really the approach that we took when we were given the challenge of how do you make electrification work.
Gotcha. So, and Christine, in talking with you, you are maybe not focusing on so much deep scope, but hopefully much broader scale of retrofits.
Right.
Can you talk a little bit about some initiatives you've been working on?
Sure. So, that is all so exciting. What you're describing, Adam, I love it. The thing is that we realize that most people, although I have to say, I'm happy that this is kind of changing. I think that the general awareness about energy and climate change and electrification has increased exponentially, even in the last 6 months. Like there's this new awakening, which is great.
Really, it's critical.
Prior to that, it was kind of tough to talk about energy efficiency with people. It was like the same old song that all the efficiency geeks were, I'm including myself. I'm not disparaging anybody. We were like, oh, nobody cares about energy. How are we going to get people to care about energy? And so we said, well, all right, instead of doing that, let's come at it from another angle and say, what are people doing to their houses anyway? What are they going to do without any care about energy? And so a while back, I did a report for DOE on the top retrofit projects in the country. What's everybody doing? And roofing and siding, kitchen remodels, bathroom remodels. But we said, hey, you know what? A lot of people reside their homes. Over 1 million houses are resided every year. That's a lot of houses. If we can touch even a small fraction of those 1 million homes and improve the efficiency, we're going to have a huge impact, more so than if we try to bring one house down to zero energy. So we said, back in, almost 10 years ago now, we got a grant from PSE&G, the biggest utility here in New Jersey, to look at reducing infiltration when residing. And that study was called Reside Tight, Ventilate Right. And so for that house, we recruited contractors, and through the contractors, we found homeowners, and we resided 17 houses. And while they were doing the residing, once they tore off the siding, we said, instead of just putting any house wrap up, we want you to detail the house wrap as an air barrier. So, they had to tape all the joints and be very careful about everything. We did blower door tests before and after, and we were able to reduce the infiltration quite a bit. On average, 20%. One house was as much as 38%, but it's because it was a real basket. When we started, it was so leaky. I was like, how did these people live here? Anyway, so that was a success, but the energy savings that we modeled based on that reduction in infiltration were modest at best. So it was sort of in the back of my mind, how can we amp that up a bit? And so then we, working with Department of Energy, we were able to do another study called Reside Right. And for this one, we used, instead of just adding a house wrap as an air barrier, we used 1 inch of rigid insulation that had an incorporated weather-resistive barrier laminated to it. A neopore product. And so we put that on the houses, and we detailed it as the air barrier and the weather resistive barrier and an extra nice R5 on the outside, because, the continuous insulation has to become a more common practice anyway for current codes. And again, we wanted this to be with regular homeowners, not the energy homeowners, but anybody who is looking to reside their house. And we wanted to work with regular contractors, regular siding contractors, to say, what's it going to take for you guys to do this? What information do you need? How much training is required? How can we make this work for everybody? And so that's the study that we're just finishing now. We did 10 houses. The infiltration reduction wasn't as high as it was with the house wrap because, you're working with a three-dimensional product instead of just a sheet product. So it was a little bit more tricky. And we were having them use a combination of liquid flashing and self-adhered flashing on the joints. And, you're dealing with existing windows. That's the other key is these houses are not getting the windows replaced because that's a big ticket item and it hardly ever pencils out. It's usually, if the windows are at the end of their useful life. But if the windows are in good shape and they're not replacing them and they're just residing, can we still do something? So our reduction in infiltration was lower. It was in the order of 10%, but then we got that nice bump of the R5 on the insulation. So depending on if they didn't have any insulation in the stud cavity, we were like, whoa, we really improved it. But most of the houses had like an R11 or something. So we're projecting that a combination of the insulation and the infiltration reduction, it's modeled to be about a 10% savings. So not amazing, but what we're happy about is we're capturing a part of the market that was not captured before. And we're trying to make this a step on the journey toward much higher performance. So a step toward electrification. That envelope's got to be in good shape for electrification. Mm-hmm. So this brings that awareness and they can go further. Now, a study that we're just starting now is called Renew Wall, like renewal, but it's spelled as renew-wall. And with this one,
gotta get the pun in there.
I just had to make that totally clear. So with this one, we're doing 2 inches of rigid insulation because from a labor perspective, it's pretty much the same as doing 1. You have to detail the trim around openings a little differently, but it's nothing that the siding people can't handle. Most of the time, they're doing that with a break on site anyway, so it's not a big deal. Anyway, we're doing 2 inches of rigid insulation, and we are using a thermal buck around existing windows, which is the product that tries to give you a thermal bridge-free install of windows when you have exterior rigid insulation. And we're doing a high-performance storm window over existing windows because, again, we've got windows. A lot of times they're still okay. But the high-performance storm windows, we're working with Brink Building Products and for the thermal buck, and Alpin Windows for the high-performance storm, and BASF for the foam. And with their light high-performance storm window, then we were look at these infrared images of our study, and we're like, oh, the wall's so much better, but look at that energy dog of a window. So now we're going to have the window taken care of, and we'll be able to do it all from the exterior, so that we're not making it too disruptive for the homeowner. And we kind of see it as a way. Everybody's excited about panelized solutions like Energy Sprung and those kinds of things, and those are really cool. But our existing housing stock is so idiosyncratic. It's like everything's different. So for a panelized solution, that seems to me like that's cool, but we have too much variety for that. This is mass customization in a way. So that one is just starting, and I'm really excited about that because I feel like with the 2 inches of rigid and the windows, we're going to get closer to driving those loads down much further and on a path toward electrification. So.
There's no doubt about that, Christine. I love the idea, and I'm curious. Is this? I know Alpin made a interior storm window. Is that what this is? That's the Windsert.
And so what's cool about this project is we're working with Alpin for an exterior install. So we are reconfiguring that. And then the thermal buck, as you probably know, is designed for install in a rough opening. We don't have a rough opening. We're going to have plywood and a window. So thermal buck. So the thermal buck and the high performance, the Windsert, is now going to be called something else because it won't work as a Windsert. And what I really love is I'm at the College of Architecture and Design at NJ, at New Jersey Institute of Technology. We have architecture students. We have industrial design students. So right now, I just had a meeting with an industrial design student. I said, these are the components we're working with. He puts them into SolidWorks, which is like the software the industrial designers work with. And then we can bring it all into Revit, and we can look at these pieces and say, okay, how do we retool these and design them for this work? So it's a great experience for the students, and it's a nice help to the manufacturers. So that reconfiguring, I should say, these materials to work for an exterior install are part of the research.
That's really cool.
Really
cool.
So, Christine, is there minimal need to get into the homes? I mean, is this with the systems you're talking about?
That is also the goal, because it's all an exterior install. I mean, we're going to do test in, test out. You know, we're going to do combustion safety. We're going to do blower door. So there's a little bit of time in the house.
For the
right.
Yeah.
But we don't need to go inside to do the work. And that is definitely part, especially, it's funny, when we designed the project, we thought, well, people like it when you're not bothering them. But now post-COVID, or it's really not post, you know what I mean? With the COVID experience we've all had, it's like, hey, this is nice that we don't have to go inside.
Okay. And so, again, is the idea that somebody needs new siding, they'll call, they'll go to not the yellow pages, they'll Google siding contractors in their neighborhood, and whoever they call, they might be able to offer something along these lines.
Well, and Rob, you're totally touching on what's so important is like, yeah, that's cool. But if it's like a bunch of people in a university and the Department of Energy, who cares? And it's like, okay, well, we need to get the siding contractors. So a lot of companies have certified installer programs. And some of them have a green certified installer program. What I would love is to come at it from several different perspectives. But one of them is, hey, can we approach the siding manufacturers and say, this is a package we've designed. We know it works. Can this be part of your siding certification program specific to this? And the tagline is like Renew Wall, a better way to reside your home. And then that's the package, so that more siding contractors can be brought into the fold to do this. That's the hope. Awesome.
And actually, I wanted to follow up with Adam about one of the things that you mentioned, Christine. You said that more people are interested in climate change and efficiency. And Adam, I'm thinking if you're trying to get a lot of people to go full electrification, whole hog on deep energy retrofits, they kind of got to care. Even if the cost pencils out, it's something that they really have to want to do. And that's one of my big questions is how many people really want to do this? How many people care about their home's efficiency? Do you have a feeling on that? Are you getting the same thing as Christine, that more people are caring?
And again, it's how you frame it. And yes, people care about climate. And I've got just a fun little graphic that we've been using in some of the marketing stuff we've been testing, which is, how much carbon savings do you get from recycling versus driving a Prius versus taking your home to net zero energy? And it's like 40x. I mean,
that's great.
So much different. It's an absolute game changer, right? And so once people see the size of the circles that represent this carbon savings, you're like, oh, yeah, I don't even need to recycle. If I have a net zero energy retrofit house, like I'm good. Like I can fly across the ocean multiple times a year and still I'm good.
Not that we're advocating any of that. But
that's right. It's like what matters, right? And so you start looking at that, and it's that carbon guilt that all these the corporations have been throwing at us to make us feel guilty individually for doing this, for being people and human and living in this capitalistic world, and you're bad and try to recycle, but that's just crazy. So if you can do something that has so much more of an impact that actually doesn't make you change your behavior, that's huge.
Well, yeah, I just want to interject just really quick too, is the company saying you're bad, so you better recycle, and don't pay attention to what we're doing.
Exactly. Right. Yeah. Just shifting the blame, and it's
Exactly.
It's nuts.
Yeah.
So partially, that answers your question, but that's really more this climate perspective. But I mean, here's the thing: when I have people over to my house, which I've taken to net zero energy, and we can talk about all the different things that I did and whatnot. But when they come in, they notice how much more comfortable my house is. They notice that they don't hear that interstate anymore. That's 3 houses down when they walk through the front door. They're like, wow, it's so quiet in here. Wow, man. It's really comfortable in here. Oh, there's no humidity in here. I mean, Florida, that's what matters, right?
Yeah, sure.
It's comfortable, but it's not freezing. Like most people's homes are freezing cold to get rid of the humidity. My home, it's comfortable and there's no humidity, right? Or the humidity's decent. So as soon as people get to experience a home like this and like, wow, this is a 1955 home. Like, this is just an everyday, podunk house in the middle of St. Petersburg. Like, how did you do this? Then they get really excited and they're like, I want to do this to my house. And, doing word of mouth, that's not
a lot
easy.
of people.
It's a lot of people
coming to your house.
But it's the more we can demonstrate it, the more we can get people to just have that experience for 20 minutes, really starts changing the mind frame, I think. So
visiting friends, family, neighbors who've done something like this, you think that's one of the biggest movers?
Of course, it's going to be way too hard to scale if that's all we've got. So, the thing that I think is most interesting now are these rebates. And so, Christine, I'm really curious to see what the thoughts are around, here we are with these, $9 billion worth of rebates coming down the line.
Yeah.
That are going to be deployed to 50 state energy offices across the country, and plus 27 billion in financing that will be available for this stuff. Now, if you add insulation to this siding project, all of a sudden you can get rebates for that project.
Right.
Yeah. If you do storm windows, you can model that. Now, though there may not be line items for interior storm windows or this exterior storm window you're doing, you may not get that in the low income program, but you can model the savings for that and get a lot of credit for those things. So you do that siding retrofit, put that together, all of a sudden, all these siding contractors, they can start taking advantage of something that they could never take advantage of before.
Yeah.
And get all these rebates. Right. So that's a big piece of the puzzle. And, and homeowners know that this climate bill's out and they're calling their contractors left and right. Like, we want the rebate. How do we get the rebates? And we're like, we don't know yet. It's about a year out. So be patient. But
a little bit of red tape
that's
first.
Part.
Yeah.
But so that's going to allow a whole different grouping of folks to talk about this in a different way and bring a lot more customers to the table, I think.
So I've 2 questions and they're related, and I'll for both of you. I'll start with you, Christine. Like the second part of the question is about financing, so you can think about that. The first part is about planning and staging. And Christine, you're talking about, well, I have to reside, so let's do something there. If we're trying to get to zero energy or dramatically reduce carbon, go full electrification, how does staging that work? How does planning it work? And Adam, I'll come to you in a second, but maybe it sounds like you're pushing for it all at once, which may be a too big a pill to swallow, scope, cost, maybe with rebates or not. But Christine, do you see, with contractors you're talking with, do you see this as kind of step one to getting to much more?
I do. And it's so interesting because when you said I have 2 questions, I was going to say, wait, I want to talk about something. And this is what I wanted to talk about. Because one of the things that is a little bit tricky with the research I'm doing is I'm only dealing with the walls. And we know there's a ton of leakage at the ceiling, right? Especially because where I'm working in the Northeast, a lot of houses have a true attic and, there's loss there. So before IRA came out, and even a while back, I was thinking this really needs to be a point where we talk to the homeowner and say, hey, for your infiltration to get even better, you can deal with the attic and then try to connect them with like a home performance with Energy Star contractor, BPI contractor, somebody like that. So that was sort of a mini piece of the whole infiltration picture. But I've been thinking a lot about how do we put people on a path to zero over time, because that is the reality for most homeowners. Most of them don't have a ton of money in their back pocket waiting to spend it on the house. Some do, a lot of them don't. I'm actually going through this right now with my house. My house is from 1926 or 28 or so. And we went through the Home Performance with Energy Star program several years ago. We did the dense pack insulation and did the air sealing and all that. But my kids keep getting bigger, so I had to add on because my son's room is kind of like a glorified closet with a window, and that was okay when he was 4, but now it doesn't work anymore. So what's interesting for me is I'm modeling the house in Passive House. And I'm saying, all right, well, the new part of the house is going to have fiberglass cavity insulation, and then it's going to have 3 inches on the outside, and we're going to do triple glazed windows. And so I'm going to have this like almost a Maserati, and then I'm going to have, like a Ford Escort on the other side. So no disparaging to Ford Escort. Anyway, you know what I'm saying? So and the plan is, the house is stucco. So the plan is, okay, that's phase 1 is the addition's going to be high performance. And then we're going to wrap the rest of the house in foam. And we're going to do high performance windows on the existing windows of the rest of the house. And the new part's going to have a heat pump. The old part still is using the boiler. Then that's going to be moving over to heat. So it's this sort of, and the tough part is you can't just give people a simple map because all the houses are different. At the same time, there's probably a better way to have some sort of base armature that says, this is where I am with my enclosure. This is where I am with my equipment. And how can I get from point A to point Z, zero energy over time? So that's really what we need to be able to provide people. And of course, it's a lot uglier in reality because it's like, we'll just do this. And then it's like, well, the railing to my front stoop is going into that wall. And if I put foam on it, it's not going to look, and then you're pulling your hair out with everybody. But that's the way it goes. So.
Yeah. So Adam, we're thinking about going much deeper. A, can you stage it? B, if you do it all at once, how do you pay for it? Easy questions.
Yeah. I mean, so to answer the staging question, yes, you can stage it, but it's got to be done in the right order. Okay. And right. So if Christine's saying, well, I need new siding. My house is falling apart. So I'm a homeowner and I'm like, my mental model is all about the siding. And I call my siding contractor. Okay, you could add this extra thing. It's a nice additional, piece of the puzzle. And boy, if he had some modeling software that could like tell you exactly how much money you'll save and what kind of rebates you get, it might actually well more than pay for that extra cost on the siding project. So depending on how all this stuff pencils out. So that's cool. Okay. If you're a furnace contractor and your mental model is, I need a new furnace. Wait, my air conditioner just went out and it's still 90 degrees in Florida and it's humid as all hell. Like, now what? Do I just go put in another outdoor unit? My father actually just went through this yesterday. I said, no, go for a heat pump. See if you can get the heat pumps, go for, and they didn't exist. They're completely out. Thanks to hurricane. Whoops. So the only choice he had is to put in a $1,300 new compressor replacing the existing outdoor unit, because that's all that really went out. But we had an opportunity to get a heat pump in there to do for all that, and we couldn't do it because they didn't have it. Right. But at that point, when you got this emergency replacement, you got to make a game time decision. And if you are not primed for this concept of a heat pump at all, it's going to be a pretty tough sell. So in our world, or what we're trying to do is we're trying to get in front of that homeowner before they have to make that decision, before their equipment actually breaks, and say, hey, do you have old equipment? We think you might, because we pull permit data and have a whole bunch of information that talks about permits. And so we can say, oh, you've got old equipment. Let's talk about heat pumps, and let's talk about how much little extra it will cost to get a heat pump compared to getting a brand new gas furnace. Right. So that incremental cost is such a huge, helpful selling point if you can get in front of that emergency replacement. Now, some contractors are going to have the full set of heat pumps on the trucks and be able to go ahead and install that no problem in an emergency standpoint if they're really with it and on the game. And, you may have this stuff sitting in stock if you're a big enough company, or you've got a good distributor that's got everything and can ship same day and all that. So the question is, if that's the case and you're dealing with emergencies and you're going to put in a heat pump, then wait, what about the envelope? What are you replacing? You're replacing a 100,000 BTU furnace with a 40,000 BTU heat pump. Okay. Now we got to deal with envelope again. And so that screws up that getting in front of the emergency replacement timeline. If you can convince them to do the air sealing and insulation and the siding first, great. Then you can do the heat pump later when that gas furnace
when you got your loads down.
Right?
Yeah.
So that's the problem with the staged approach. Yes, you can stage, but you have to do it in the right order. Or like in my case, I went ahead and had the heat pump done before I had the windows put in, but I sized the heat pump for post new windows because it was done in February, March. Many months before I knew the windows were going to show up. And then by the time peak cooling season came along, I would be okay. Right. So that's not a multi-year staged approach. It's a 3-4 month staged approach, and that works just fine. But we modeled the whole thing ahead of time. So we knew what size we had to be able to target, like what size system are we going to put in when the peak season does come around. Right. And it did fine. Since it wasn't peak season, it kept the house comfortable. So those are the types of things you look at there. But in terms of how do you go all in, financing is the key. And, again, I mentioned earlier, there's $27 billion of new money going into the green banks to help with this financing. And so that's going to be huge. The key thing here is to get that interest rate down. Like, I hope that they can really make sure that that's subsidized, and so that the interest rates are low. Low interest financing not only is really cost effective, it helps the cash flow make a lot of sense for these larger retrofits, but it also is really attractive to consumers. If a consumer's out there like, oh my God, my mortgage rates are now 7%. And I can get 2% financing for my home remodel and retrofit. Oh, well, I want that, or even 4%. And it used to be the other way around, where all this energy financing was 7-8%, but yet, like, heck, I could refinance my home and get it for 3%. Why would I dare do that? So you were fighting in the opposite direction. So who knows what that's going to look like now? But that financing is so important to making all this start to make sense. And even that 5 cents a kilowatt hour I paid for my solar system, if I would have financed that on a 20-year loan, I still would have been coming out at 9 to 10 cents a kilowatt hour. From day one, I'm still 3 cents less than the grid. So,
Have either of you seen financing mechanisms or any other mechanisms really be to make this a lot more accessible to lower income people? That's something that I've seen programs really struggling with. That, it's not the people who really have this bigger energy burden taking advantage of these programs and of these dramatic savings. And I don't know how to do that. Have either of you seen effective strategies or ideas to
block power
to get at that? Okay. Yep.
They're the leasing model, right?
Right.
They take on all of the infrastructure cost, and they basically sell you heating and cooling as a service, right? It doesn't matter what your credit score is. They take on all that risk. They do all the retrofits, and they sell you heating and cooling as a service.
Cool.
Sealed is another wonderful vertically integrated company doing similar work. right? And they've got a financing model that you only pay them back on the loan based on how much you're saving off of your bill. So your bill does not change at all, but you get all the increased comfort and benefits and of that until the loan is paid off. And after the loan is paid off, all that stuff is free now, and you've got a much reduced energy bill. All right. So there's models that can do it. I think the other big thing is 40% of all this new money is got to be geared towards low to moderate income.
Right.
And the the electrification rebates component of the climate bill is for some $1 billion in line item rebates for low to moderate income. So you got to be less than 150% of area median income. And if that's what you're making, these rebates are incredible. If you bundled the rebates and did Christine's solar, siding project, right, with the line item rebates and got the modeled rebates for the siding and the windows and got the line item rebates for this, that tops out at $22,000 worth of rebates.
Wow.
And you're probably looking at maybe a $30,000 total project. So in that case, if you're in the lower incomes, you would have to finance, $8,000 maybe. And then you have the financing. Of course, you got to deal with, how do you finance, if your credit score is really low, right? If this new financing does not have some methodology to still loan to people with low credit scores, or debt to income ratios and things like that, I think that's going to be crucial for deploying this financing. But it's already designed. It's got to target 40%, low to moderate income, or it's got to be hit those disadvantaged communities. So I think it's going to happen, and I think there's going to be a lot of opportunity for a broad spectrum of folks to get the fully deep energy retrofit and affordably. So
cool. I can't believe we've already been talking for almost an hour.
Wow.
I guess one question I wanted to ask both of you, Christine, are there any just awesome slam dunk scenarios that come to mind, or just fantastic projects or fantastic programs where you've just been really impressed with successful home energy retrofit scenarios? I've seen things that really work.
It's funny because here in New Jersey, the 3 programs that are mostly used are Home Performance with Energy Star, Comfort Partners, and then the Weatherization program. And it really seems to be the goal. Where you land on savings is so driven by the programs. And I feel like it's even, at least within Home Performance with Energy Star, it's so driven by what the contractor is kind of focusing on, whether they're mechanically focused or they're, enclosure focused. And most of ours don't seem to be as focused on the enclosure. So they're looking more at the equipment. And that has me a little bit concerned because of the things that we've been talking about, that if we want to go toward heat pumps, then the enclosure is kind of left behind. So I know you're asking for positive. That's not so positive, but that's something that I'm a little bit worried about. And I think that some of the approaches that are being taken, like statewide, the NYSERDA programs that are trying to look at successful retrofit projects in New York in particular, I think those have been great case studies for people to potentially follow. Multifamily housing, affordable housing. How do you get these to perform well? And then how do you set up case studies so that other professionals can follow in those footsteps and do the same thing on more buildings?
I think case studies, I would love to see more case studies, and on both sides, like case studies just for consumer level case studies, right, with, real people, real buildings, real energy bills, and then deeper case studies for the contractors,
right,
if it's like, this will never work. Oh, hey, look, here's the data. It worked perfectly.
Right.
Adam, any great success stories that come to mind? program level, or one house that you thought was awesome, or?
Mine, no.
Yeah, nice, awesome.
I mean, it's
awesome.
fun, right? I mean, it just just doing it yourself is super interesting. Getting to eat your own dog food is always the thing. You like
great
you
analogy.
talk it, you preach it. Now actually go do it. Oh man, it's really hard. And I think that's the biggest thing that I've learned from this process of managing a complex net zero energy retrofit with 5 different trades in my house.
Yeah, right.
And especially in a new area where I don't know any of the trades. And so I'm starting from scratch, not going to the yellow pages, but to the Google reviews and, finding 3 or 4 contractors to come and give you a bid from each of the trades, because down here, there's no vertically integrated anything. Like nobody's like thinking home performance down here. So it's humbling and interesting. And it's like, oh man, can we build solutions? Can we build tools to bring these pieces together to help facilitate project design, to help educate the consumer and make this all way easier? Because I probably put in 150 some hours of my life just into figuring out what needed to be done to this house, finding the contractors and pulling the trigger on it.
Yeah.
Right. And we got to be able to do that in 5 hours. And,
at
least,
Yep.
and then make it cost effective and get everybody on board. So I think there's a lot of different solutions. I'm really excited for the new BPI certificate that they're coming out with. This is, and I think Robb was on our committee with that. But it's this new home decarbonization specialist is a certificate from BPI that's above building analyst that's going to really test and create a new role of an individual who does project design for whole home and really thinks through envelope improvements, heat pump requirements, sizing, equipment, ductwork, all of that. And then what kind of solar might be contributing to that, brings all the economics together. This person knows energy modeling. They know the building science. They know how to communicate with a consumer and tell and explain how all this works together with the homeowner. And once you have that spec, once you've got the design, you can go to any insulation contractor and say, I need you to get this amount of insulation into this attic in this way, and go to any HVAC contractor that sells a Daikin or a Mitsubishi or whatever it is you want. I need this spec, put in one of those. And now you get apples to apples bids. Mm-hmm. And while we haven't proven this and gotten it out there, this is the idea that I think is going to allow this whole thing to come together. As the rebates get deployed and as technologies continue to increase and improve, that's going to be crucial, because I don't see a lot of new home performance contractors coming online to be, there's going to be the vertically integrated folks, right? And they're out there, but they can only do so much. They're not going to be able to do 80 million homes.
Right.
And there's a reason why you have where there's no national HVAC companies. There's no national insulation companies, right? You have plenty of national, card companies, and there's so many different explanations. I probably come up with better examples there, but there's lots of national corporations that do all different kinds of services, but not in this space.
Mm-hmm.
So maybe you might have just answered my last question, which is, if we were to talk again in 5 years, what do you hope we'd be talking about?
That this whole thing has been really successful, and most homes are now electrified, and we've done at least 40 million out of the 80 million by then. That's what we got to do. But we'll see.
Christine, if we were to talk again in 5 or 10 years, what do you think, or what do you hope we'd be talking about?
I would hope that, we've seen this complete excitement and adoption of low energy homes, and that we're moving on to discussion of regenerative buildings and, actually improving our surroundings with our buildings and having them function more like, like trees and, moving to the next level with this. So,
I love that.
And having it feel like, something that people, that the people who are doing the work can have pride in what they've done, and that the legacy of what they've done is something that they can feel aligned with their values. Like, we've done the right thing, and we're as goofy as it sounds, we're making the world a better place. So
yeah, absolutely. I mean, yeah, I take pride in my work. It's
right.
You both do, clearly. It definitely shows, and that's awesome. And I love working with contractors who do the same thing.
Yeah.
Yep.
Fantastic. Awesome. Well, thank you both very much. That was a really fun conversation.
That was. Thanks.
Good. That's awesome.
Thanks again to Adam and Christine. We have links to their info and their organizations in the show notes. We also have links to several of the other resources we mentioned. Buildings and Beyond is produced by Stephen Winter Associates. Visit swinter.com/podcast to see the show notes. That's swinter.com/podcast for show notes and other episodes. And check out our careers page if you are interested in exploring opportunities to help improve buildings. We have offices in DC, New York City, Connecticut, Boston. Actually, our Boston office recently moved to Somerville, to Greentown Labs in Somerville. Thanks for listening, and thanks to the podcast team here, especially Alex Mirable, who really does a lot of the heavy lifting, producing this podcast, and also editing many of the episodes. Thanks again.